Alright guys, I'm going to do a quick video over using Moveit for ROS. And to begin, we need to get a URDF model or file. So they're a little hard to find, but if you just type in some robot name and then URDF, you can typically find something on GitHub. Here I see URDF, and I see it's got a couple models. I found that they don't always work, so you just kind of got to peck around and find what you're looking for. So anyways, your first step would probably be to just clone this. So git clone and then this URL. And I've already done that, so let's go take a look at where that is, just so we know it's not that. Okay. So I actually put mine in my catkin, which isn't necessary, but I'm just keeping everything here. And this is what it looks like. So here's my URDF. So we need that file path. So what we need to do is open up the Moveit setup. So I'm going to ROS launch, and then it's Moveit _ set up assistant set up assistant.launch. Here it is. Okay, so we're going to create a new Moveit configuration. I'm going to browse. And here it is. I'm going to pick the 1600 model. And there we see it. If you don't see anything in this box after you click load, that means you have some sort of an issue. So first step is, well, we're just going to go through these tabs from top to bottom. So first one, self-collision. All you got to do is generate a default collision matrix. Then we'll set up virtual joints. So this, if you just want the robot arm, you don't need anything here. But I actually want this robot arm to be on a mobile robot. Obviously this isn't an ideal arm to do that with, but I'm just picking a random arm that I happen to have on my computer. So anyways, just doing it out of theory. So virtual joint, and then child link and parent frame. So child link says which link do I want to be attached? Well, it's going to be the base link, which is this bottom guy. And then what do I want to attach it to? Actually no. What I'm going to do is I'm actually going to attach link 1, which is this link, this one here that rotates in the Z direction. And I'm going to attach that to base link. So this is a little confusing, but this base link is actually going to be my mobile robot. So base link is commonly used for that. And when I do this, it'll get rid of this base link that'll, I guess, kind of form into one. So what type of joint do I want? I actually want a fixed joint, so I want the robot base to be fixed to the mobile robot base. There's two other options, floating, which you could use for quadcopters, and then planar if you want to build the robot entirely in Moveit, but that can only handle holonomic robots, which basically is just robots with mechanism wheels, meaning it has 3 degrees of freedom. It can rotate, go forward, and go sideways. In our case, I'm going to be using a non-holonomic robot, which has 2 degrees of freedom, forward and rotation. It's just a differential. It's actually a skid steer robot, which essentially is a differential steer robot. Anyways, I want it to be fixed. Planning group. Okay, so this is for the kinematics. Just gonna make an arm. Pick a solver. I'm just using this generic one here. then add my joints. So see, notice how I don't have base link anymore, and joint 1's my first link here. Well, my first joint. These are the joints that make up my robot, and this is a tool, so I'm not going to include it. Save. Okay, and I'm going to make one more. It's going to be the grouping tool. Okay, I'm doing this because if you don't put it in, then it'll yell at you and it won't let you finish. So even though I don't have a gripper, I've got to say that I have a gripper. And that's just kind of part of the kinematics. It needs a end effector. So to check your work, well, obviously you can. This is for adding poses, but this I don't add poses. I just check my work with this. If you see that all your joints are, you can actuate them, then that means you've done it correct so far. And then on the gripping tool, I don't have one. Nothing to actuate. There's no joint there. So that was just to check. So nothing needs to happen there. End effector. So this, again, I don't have per se an end effector, but you have to put something. And then parent link. So basically, what does the tooling attach to? In my case, we're going to say link 6. And you can leave parent group blank. Unless it throws an error that you need one. No passive joints. All my joints are actuated. Then I'm going to pick a place to put this. I've already got a series of these, so I'm just going to next in line. Moveit, ABB, mobile, 5. So yeah, I know it's kind of silly. Oops. Some sort of bug where it doesn't, you got to click in the window to get your file to stay. Probably not a bug, just me. Mobile 5. Click. Alright. And then generate package. And that worked, so exit. If it doesn't work, then typically it'll throw an error that is going to be informative. All right. So again, I said earlier, we are going to be operating on a mobile robot. So the mobile robot is completely up to you. I'm going to be using a Pioneer. There we go. Okay, so the idea is as long as you have a robot that you can input command velocity and then get out odometry, then that robot's going to work for you. In this case, I have a Pioneer set up in Gazebo, and again, you don't need to do anything fancy with Gazebo. You don't need to do anything with Gazebo. It could be just any simulator, or it could be a real robot, or you can just send a command from the command window. Anyways, I'm just going to let this guy spin so that I know that it's going to be printing a changing odometry so that I can tell when my robot arm is moving. So we'll put him away. Open up a new terminal, and then now we're going to start Moveit. So I'm going to say ROS launch, and then the name of my file, so move, what I call it, Moveit, ABB, mobile V5, and then we're going to run the demo. Okay, my tab's not working, meaning maybe I selected the wrong one. Moveit, ABB, mobile, V. Oh, okay. So it's not V5. Oops. 5, and then demo. There we go. Okay, so this isn't going to be too beautiful. The reason is, okay, sometimes my RViz crashes. It's not going to be too beautiful because my robot that you just saw in Gazebo I'm having some trouble getting that to appear in this window. So we're just going to have a robot kind of floating and riding around in space, but we know that it's actually sitting on the robot, the mobile robot. So there's this bug. Here I go, calling everything bugs, but this one seems like a bug. That is coming in large, the little controller there, so I'm going to tune that down. This is on 0, but if I put it on 0.2, I'll take care of it. So this is kind of what typically happens when you use Moveit. You kind of get this arm, you can pull it around. So this is just kind of forward kinematics going anywhere, and then inverse kinematics to travel in a particular Cartesian direction or any generalized coordinate. So a couple things to realize. So planing group determines, oh boy, battery's low. Planing group determines what you can manipulate. So if I had a gripper on here, I could select this, and then I'd be able to manipulate my gripper. So I don't, so who cares? And then planing. So you have different type of motion planners. Honestly, I'm not familiar with any of these, but I kind of understand the concept. And then I've read that this is kind of the one to go to. So RRT, connect K, config default. And I don't know how accurate that is, but again, that's what I read. So here we can select a beginning state and a final state. So final state will be random valid. So my initial state is this solid orange, and then this transparent orange is my final state. If I plan, oh, I had it backwards. But see, it's just planning a path and showing you what that path looks like. You can stop that by pushing reset. So next thing I'm going to show you is how to control this with a joystick, so Xbox controller. The only thing you need to do in the Moveit configuration is select this. This is allow external communication. At least I assume that's what that stands for. So now I can have an external input, but I'm not done. I actually have to launch something. So ROS launch, and then this is automatically created. Moveit. We said it was ABB mobile 5. And now this time, I don't exactly remember, so let me go look. So again, this is just automatically created when you use Moveit. You get a joystick control. So I see it right here, joystick control. So should probably do it. I could have figured that out. Okay, so let's push enter. And if I don't see any errors, then that's great. Earlier I was getting some errors with it not liking the parent link. But anyways, seems to be working. So I've got my Xbox controller here. I know you can't see, but I can, this is my left analog stick. And then my bumpers. I can control the Z axis here. And again, this is inverse kinematics. I'm constraining it. Oh, let me get my chart. So if you've ever done kinematics, we know that inverse kinematics is much more of a pain. That's why you rarely see robots above 6 degrees of freedom, because the kinematics becomes very difficult. Here I'm pivoting around a point. See, I can't really tell, maybe that's pitch or something. Anyway, so that's that. And then we were going to control this on a mobile base. Well, actually that's already done. See, it's on the platform, which you can't see. All I got to do, I'm going to go to my frame, my reference frame. So what do I want to reference as my fixed frame? And honestly, I don't super duper remember. So odometry, that kind of makes sense. So now my arm is actually traveling around with my robot. So that's pretty great. So I stop it, turn So that's pretty slick, I think. So let me do that and see if I can control it with the joystick still. And looky there. Not real sure why it's being so jumpy, but I guess I can't complain. It is quite a bit to ask. So I think that's all I have. Thanks for watching.